Hi guys, welcome back. For today's activity, we are going to be exploring more about manipulating chemical quantities, but today we're going to introduce the idea of using mass to do so, and not just mole to mole ratios, but can make it even a little bit more complicated. We're still doing stoichiometry, and sometimes people call this section of chemistry probably like the most difficult. Kind of bummed I can't be there with you in person to help you out, but if you guys have any questions at all, I'd be more than happy to set up some one-on-one time with you to either go over this like via chat or with an online one-to-one video like this one. But for today, I'm going to go through a bunch of different examples for you, and then you can kind of watch them over as need be. And then please reach out if you have any questions. So today we're on page 83 in your notebook, and you can go ahead and write down the DRQ. You'll notice we're still answering that same question. How can we quantify chemistry? Because we're still worrying about how to make predictions using calculations and math. And then the DRQ, though, is very complicated now, right? It's not just, how many molecules or how many moles. Now we're saying, what mass of iron is needed to react with 2.02 grams of H2? So now we're getting really specific. Now we're saying, okay, if I mix this quantity of iron with this quantity of hydrochloric acid, how much hydrogen gas will I get back? And this is real chemistry. This is where we really start to get into some really cool, predictable stuff. So go ahead and copy that down, and then we're going to take some notes today on stoichiometry. So in order for us to start today, we need to think back to the video I asked you to watch last class about my son making a sandwich. So in order for my son Nico to make that sandwich, I had to go to the grocery store and do some shopping. So Nico asked that he be able to make a sandwich that had 2 pieces of bread, 1 piece of cheese, 3 pieces of meat, and 2 dollops of mayo. But that's not really how you shop for stuff at the grocery store, is it? Have you ever been to the grocery store with your family and shopped in the deli counter? Or even for a loaf of bread? You know, you don't go to the grocery store and say, all right, I need exactly 3 pieces of ham, please. That's not how it works, right? How do you buy ham at the grocery store? You have to buy it by the pound. You have to buy it by mass. And if we go to the grocery store and we're shopping for, let's say, even bread or mayonnaise, you buy it in a mass-based quantity, a package that is regulated by how heavy that loaf of bread is, or how big or how heavy that jar of mayonnaise is. Cheese, we buy it by the pound. We don't buy it by individual slice. And chemistry is exactly the same way. We don't measure anything in chemistry by the number of molecules or even the number of moles. Instead, we do it by mass. We go into the lab area and we weigh out a particular quantity by mass. The challenge, though, is that when we get into the kitchen or in the laboratory, we don't create anything by mass. You don't make a recipe by saying, oh, I need exactly this mass of bread. It's how many individual pieces of bread or individual atoms or moles of atoms in the laboratory. So today we have to figure out how to connect all of the ideas that we've been working on. Moles, relative quantities, in order for us to figure out, well, how much mass of one thing can equate to mass of another. So let's see what I'm talking about. We'll stick to the grocery store chemistry first, just to make sure that everything is easy, and then we'll transition into learning some chemistry today. So let's go back to my son making a sandwich, shall we? And manipulate some quantities about that. All right, so here we go. So in order for Nico to make a sandwich, he wanted to use some mass and meat. So some mass of cheese and mass of meat. So in order for us to do that, we need to know just how heavy each of those individual things are. So these are not true, but for the purposes of this activity, we're going to pretend they are. So we're going to pretend that the mass of a piece of cheese is 450 grams. So if the mass of a piece of cheese is 450 grams, and I want to know what mass of cheese should I buy to use up 300 grams of meat. And so to do this, I usually would rewrite the entire chemical equation, though it's not going to fit on my board here. So I have it for you guys right here. And I would also look at it carefully. So I'd say, okay, if I have I always start with what I know I have, which in this case is 300 grams of meat. And I'm wondering how many grams of cheese that means I need. Now, it would be amazing if we had just one proportion that could help us figure out how to get from grams of cheese to grams of meat. But we don't have a proportion. The gram to gram proportion does not exist. No matter how hard and how much we wish it did, it does not. And so in order for us to figure this out, we have to go from grams of one thing to a quantity from the chemical reaction. Okay? And then we got to go back to grams. So this comes from the reaction, this relationship in the middle. Okay? So let's talk about that for a second. So we're going to start with the grams of meat that we have. So if I have 300 grams of meat, and I want to know, well, how much or how many units of that is there? So how many units then would that be? So I look at my chemical equation and I look at these relationships down here. So if I have 300 grams of meat, how many units is that? Well, I don't know. But what I do know is that for every 1 unit of meat, it weighs 125 grams. So now I can cross multiply and figure out my units. So I have, let's see, 125x equals 300. And in order to solve for x, I need to divide both sides by 125. And so x is equal to, let's see, 300 divided by 125 is 2.4 units of meat. So now that I know that I have 2.4 units of meat, now what I can do is look at my chemical reaction up here and figure out, well, if I'm going to use 2.4 units of meat, how many units of cheese does that mean that I need? Now, in order to do that, I have to look at the relationship from the chemical reaction. So let's look at that relationship. The relationship for cheese to meat from our chemical reaction is it's a 1, 2, 3 relationship. For every 1 piece of cheese, I need 3 pieces of meat, but I don't have 3 pieces of meat, right? I have 2.4. You say, okay, well, if I have 2.4 pieces of meat, how much cheese does that mean I need to buy? So we need to cross multiply and solve for x. So 3x equals 2.4. So x is equal to 2.4 divided by 3 is 0.8 pieces of cheese. But again, we can't go to the grocery store and buy 0.8 pieces of cheese. We have to buy it by mass. And this is where it takes one extra step. So that extra step there for us is going to be, okay, if I have 0.8 units of cheese, how many grams is that? I know from my relationship here that every 1 unit of cheese weighs 450 grams. So I can cross multiply and solve for x. And when I do that, x is equal to 450 times 0.8 is going to tell me that I will need to go to the store and buy 360 grams of cheese. That's crazy. That's a lot of math, right? But the relationships are all there in this chemical reaction and in the amount of mass per unit for each item. So we're not coming up with any of these numbers. They're all here given to me. I'm just using them to relate quantities to each other. So let's try it again. Now let's keep in mind that there's a process that you can kind of follow, right? We got to go from grams to unit and then to grams again. So sometimes I even write it a little longer. I say, okay, so we're going to go from grams of the thing that I know to units of the thing that I know. We're going to go use the chemical reaction then to go from units of the thing I know to units of the thing I don't know to grams of the thing I don't know. All of this information is going to come from the chemical equation. And this information are going to be given to us by the amount of mass per unit. In the case of chemicals or elements or compounds, that information is actually going to come from the periodic table, but we'll get to that. Okay, so now let's look at our next example using that guideline. And we'll ask ourselves, okay, well, what if I want to use up 500 grams of cheese? How much mayo should I buy? So we look at our relationships again, right? We start here. Grams of the thing I know to units of the thing I know. In this case, I know that I have 500 grams of cheese. So how many units of cheese is that? So if I have 500 grams of cheese, how many units of cheese is that? Well, I have to look at my relationship over here that says that there's 450 grams of cheese in every 1 unit of cheese. Cross multiply and solve for x. 450x equals 500. Divide both sides by 500. And we get 450 divided by 500 is x equals 0.9 units of cheese. Now, if I know, this is step 1 right here, right? So if I know that I have 0.9 units of cheese, then I can try to find a relationship between the units of cheese and the units of mayonnaise. So what is the relationship of units of cheese to units of mayonnaise that we're doing sort of here for step 2? Well, we have to look at the chemical equation for that. So if I have 0.9 units of cheese and I want to know how many units of mayo that means, looking at that chemical formula, I know that for every 1 cheese, I need 2 mayo. So we cross multiply and we solve for x, and that is 1.8 mayo. Okay? Which leads us to the last step of our process, which is right here, to go from units of the thing I don't know, which was our mayo, to grams of the thing I don't know, which was our mayo. So we'll go down here, step 3. Well, I do know that I have 1.8 units of mayo. I don't know how heavy that is. What I do know is that for every 1 unit of mayo, it weighs 3 grams. And I know that from this relationship right here. So if we go ahead and we cross multiply and we solve for x, we find that x is equal to 3 times 1.8, which is 5.4 grams of mayo. So if I wanted to use up 500 grams of cheese, then I would have to go to the store and make sure I bought at least 5.4 grams of mayo. Are you with me? Okay, let's try it one more time. We're going to try it one more time, and then we're going to sort of transition into chemistry. Okay, here we go. All right, so what mass of bread would I need in order for me to use up 480 grams of meat? So what mass of bread is needed to use up 480 grams of meat? Notice I'm reading it more than once because it's important that I understand what all those numbers mean. Keep track of them all. So let me take a look. Okay, I know I have 480 grams of meat. What I don't know is how many grams of bread I will end up needing. Okay, but I know that the first step is to go from grams of what I know to units of what I know. So 480 grams of meat, and I don't know how many units that's going to be. So I have to do a calculation here. I have to say, okay, well, I know that for every 450, oh no, I'm sorry, that's for bread. For every, where's bread? Where's our meat? Right here. So for every 125 grams of meat, I have 1 unit of meat. So cross multiply and solve for x. We find that 125x is equal to 480. Divide both sides by 125. And x is equal to 480 divided by 125. 3.84 units. Okay, of meat. Now, units of the thing I know to units of the thing I don't know. And I don't know how many units of bread that means. So if I have 3.84 units of meat, how many units of bread does that mean? Well, they have a relationship from the chemical formula of a 3 to 2 relationship. So that means that 3x is equal to 2 times 3.84. Divide both sides by 3. And x is equal to 2 times 3.84 divided by 3, 2.56 units of bread. Okay? Now, we can figure out how heavy those units of bread are. So let's see just how heavy those units of bread are. Well, 2.56 units of bread divided by an unknown mass, because we don't know yet. But what we do know is that every 1 unit of bread weighs 450 grams. So x is equal to 450 times 2.56. So we get 1,152 grams. And that's it. So you'd have to go to the store and make sure you bought that many grams of bread. Okay? So now that we've done this with things that you are familiar with, let's do it with things that you are not as familiar with. The process is exactly the same. Nothing changes except we're going to swap the word unit out with the word mole, because that is what we use in chemistry. Okay? And instead of the relationship of grams to mole coming from the slide, the relationship of grams to mole is going to come from the periodic table. Okay? So let's look at an example together. All right. So let's imagine that we had a reaction in which iron reacted with hydrochloric acid to produce hydrogen gas and iron chloride. How many grams of HCl would be needed to produce 3 grams of hydrogen gas? So now we need to collect some information. First of all, we know that we are going to use a quantity of 3 grams of hydrogen, right? What we are trying to figure out is how many grams of HCl that would produce. Now, we do not know. There is no direct relationship between that. We have to go from grams of hydrogen to moles of hydrogen. Then we're going to use our equation to go from moles of hydrogen to moles of HCl. And then once we know moles of HCl, we can figure out grams of HCl. And this is where it gets long, but not impossible. Okay? So, step 1. Grams of what we know to moles of what we know. What do we know? We know that we have 3 grams of hydrogen. We don't know how many moles of hydrogen that is. Where can we find the molar mass of H2? The periodic table. The periodic table tells us that for every 2.02 grams of H2, that we have 1 mole. Cross multiply and solve for x. So we say 2.02x equals 3. Divide both sides by 3. And x is equal to 2.02 divided by 3 equals 0.67. Oh, I did that wrong. Sorry, guys. Divided by 2.02 to get x by itself. See what happens when you guys aren't here to fix it for me? This cancels out, and x is equal to 3 divided by 2.02. 1.49 moles of H2. Now, we're not finished. We only figured out how many moles of H2 we started with. Instead of using 3 grams, now we can actually use our chemical reaction right here to find a relationship between H2 and HCl, because they are related by their mole ratio relationship from this equation. So, we know now that we have 1.49 moles of hydrogen gas. So, how many moles of HCl does that mean that we are going to produce? So 1.49 moles of H2, and we know that the relationship between moles of H2 and moles of HCl from our chemical formula is a 1 to 2 relationship. So it's for every 1 mole of H2, we need 2 moles of HCl. Now we can cross multiply and solve for x, and we'll find that we have 2.99 moles of HCl. Now, that tells us the moles of HCl, because we went from moles of what we know to moles of what we didn't know. And now we have to figure out, well, moles of what we didn't know to grams of what we didn't know. And again, that information is going to come from the periodic table. So 2.99 moles of HCl, we don't know how many grams that is. Oops. But what we do know is that every 1 mole is equal to the molar mass of HCl. From our periodic table, we know that hydrogen is 1.01. We know that chlorine is 35.45. So when you add them together, we get 36.46 grams in every 1 mole. Cross multiply and solve for x, and what we're going to find out is that x is equal to 2.99 times 36.46, 109.02 grams of HCl. And that is how you would do that for an actual chemical equation. Let's try one more example. One more example before I ask you guys to kind of work on some of these on your own. So here's your last example. Okay, how many grams of Fe would be needed to produce 300 grams of hydrogen gas? So again, we know we have 300 grams of hydrogen gas. What we don't know is how many moles that is. Step 1, grams to moles. Step 2, moles to moles. Step 3, moles back to grams. Okay, so we know that the relationship between grams to moles for hydrogen gas is that every 1 mole weighs 2.02 grams. We got that from the periodic table. Cross multiply and solve for x, and we find that 300 divided by 2.02 is 148.51 moles. Awesome. Now, and that's moles of H2. Now, we need to use that value to figure out, well, how many moles of iron does that mean that we will produce? Well, if we have 148.51 moles of H2, and we don't know how many moles of iron that would be, but what we do know is that iron and H2 have a 1-to-1 relationship. So, for every 148.51 moles of H2, we also get 148.51 moles of Fe. And if we know that we have 148.51 moles of Fe, we can easily determine for part 3 how many grams that is by looking at the periodic table and looking up its molar mass. So the molar mass of iron is 55.85 for every 1 mole. And if we cross multiply and solve for x, we can see that 55.85 times 148.51 gives us a very large number. It is, I don't know if you guys can see this, yeah. X is equal to 8,294.28 grams. And that's how much iron would be produced if we were to use 300 grams of hydrogen gas. It's a lot of hydrogen gas. Okay? Again, if you guys have any questions, please do not hesitate at all whatsoever to reach out to me. I'm going to give you guys a couple practice problems to do for homework. I'm only going to give you like 3, I think. So you guys can kind of, not tonight. Today, you're just going to take these notes. That's it. Next class, you guys are going to practice a little bit. And then reach out to me while you're doing the practice. Let me know how you feel about it. If you need more days to practice, more practice problems, I'd be happy to create that stuff for you guys. I miss you lots, and I hope to see you soon. Bye.